Okay, welcome everyone to today's compiler architecture meeting. So on today's agenda we have one topic, but I think that it might actually generate a fair bit of discussion. So the discussion today is going to be around Trill, which is a sort of a testing interface for the compiler technology. And it was developed, for those that aren't quite aware, it was developed about I guess started about a year and a half ago to help with testing of the language agnostic compiler, and a fair bit of work went into it over the summer of 2017. But since then, a lot of the work had been stopped just basically because of no people to work on that. So. But it is still fairly important for us and this project, and I think that to help move things forward, it would be useful if we did have sort of a list of work that needs to get done, and a prioritized list of work that needs to get done, as well as a description of what that work actually is, so that those that do want to help out have something to grab onto and go for it. So. The issue that I opened to just list some basic ideas based on discussions that I knew of at the time and discussions that I've had with other people is 3210. So you can kind of follow along there, or add your comments if you happen to have any to that particular list. But what I thought that we could do today is to actually go through that list and talk about what each of the items are. If others have ideas of things that they'd like to see in Trill, by all means mention those here, and then hopefully we can go through and prioritize the work that's there, so that we can have something to go with. Okay, so I guess the way that I'm going to approach this is to basically go through the items that I have in that issue one by one, hopefully give a somewhat cohesive, cogent description of what they are, and then we can maybe have some discussion on that. So the first is replacing the FE test opcode tests with Trill variants. So prior to Trill, the way that the way that we had tested the different opcode semantics in the compiler was to actually manually write test cases using Vial Injector. While that worked, the challenge with that is that each platform, x86, Power, Z, ARM, ARch64, whatever it happens to be, needs to write its own set of tests for that. And in many cases, it's basically just duplicated code. This isn't a great way of doing it, and it's the kind of thing that Trill can actually do really well. So the idea is to actually take those tests and the coverage that they are, well, basically replacing those tests with Trill variants of them, and then deprecating them and eventually deleting them altogether. And the advantage there is that we have one set of tests that we know is going to be available on all different platforms. As it turns out, there actually is work started on this already. If you're aware that there's an ARch64 backend port underway, and the way that the team that's kind of working on that is operating is under sort of a test-driven development model, where they are trying to produce Trill tests for each of the back-end evaluators that they're writing, and with the goal of building up sort of a body of test cases as they go. And what's going to end up happening is that because they're starting from scratch with ARch64, they're really going to get full coverage of all the different opcodes. So I think that this particular task is going to be covered by the work that's going on with ARch64 right now. So the only wrinkle in that is that that work is probably going to take months to complete. So we may not have a full set of test cases for several months yet, but that might be just fine. So, any comments or thoughts on that particular point? Okay. The next is allowing platform and capability-specific tests. So there actually already is an issue open for this particular item, so 1843. One of the problems that we see is that even if you write a test in Trill, there's no way for there's no way to distinguish whether or not the features that are being tested are available on a certain platform. So, for example, if you're running a test that uses SIMD or vector instructions, there's no way of determining at the moment. There's no way of determining whether or not those features are available on the test system that you're actually running on. So there needs to be some smarts built into I think the test infrastructure, as well as perhaps even to the way that some of these tests are written to allow them to be selectively disabled or enabled depending on the features of the target environment. That sound about right? Yeah. Yeah. Any thoughts, comments, and? Yeah. Yep. Okay. The next is to remove the dependency on JIT Builder. So right now, when you want to build Trill, you also have it also has a dependency on JIT Builder. That doesn't necessarily have to be the case. There actually already is an issue that kind of tracks this particular kind of work and allowing you to choose different backends for it. I'm not super familiar with all that this entails. Are you, Leonardo?
Sure.
Just give a quick description.
So basically, what that issue was for was trying to replace the JIT Builder library with the test compiler as a backend. And the reason this is needed is because right now the OMR compiler can't be built as a standalone library. It needs extra pieces to be injected. And so that's why you currently have to add in the pieces, and the original approach was just to use what JIT Builder provided because that was already available. Then some work was done to make it so that the test compiler could be built as a library, and making it so that Trill could link against the test compiler and include the correct headers when needed so that it now runs with the test compiler instead of JIT Builder. That was mostly still at a prototype stage, not very complete.
Okay.
The current state.
So this work is to continue on there and cut the cut the cord with JIT Builder. Okay. Okay. All right. Okay. So the next item I had on my list was to persist more of the compiler environment in Trill and provide the ability to reconstruct that environment. So one of the goals of testing with Trill was to be able to produce test cases from the output from the compiler. So at the moment, we can actually output sort of a representation of the intermediate of the nodes that build up the intermediate representation, and we have a means of actually feeding that back into the compiler. But the state of a compilation includes more than just the nodes. It includes things like the flags on the nodes. It includes symbols and symbol references, and perhaps some other things as well that are important to capture, so that if you want to do a faithful reproduction of a very specific compile, you have all the information you need in order to do that compilation. So right now we can output node information, but we can't really output much else. So what we do need is some means of persisting some of the other internal information in the compiler, like the symbol reference table, symbols, node flags, that sort of thing, and allow the ability to re-inject that into the compiler for testing purposes. About more than a year ago, I know Leonardo did try and attempt to put some a design together for persisting the symbol reference table. The issue is actually now, the pull request is now closed. It's 1552, but it was closed more due to inactivity rather than the ID being invalid. So I think what will actually have to happen is that that particular pull request will need to get revived and perhaps refreshed with some fresh thinking, because we haven't thought about it in a year and a half. But that's just one idea for moving forward with a symbol reference persistence model. And I think it also included node flags, didn't it? Or was there a separate one for that?
Yeah. So it didn't actually persist node flags yet. Mm-hmm. What happened was the big challenge with persisting the symbol reference table is the number of enums enum values that have to be serialized. Mm. And so a lot of them basically have to be just stringified. And to avoid having to manually maintain the enums and an equivalent array of strings, what I did was create a macro mechanism that kind of just built out both the enums and the array of strings. Mm-hmm. And that I experimented with both the symbol reference table and the node flags. So it converted some enums in both classes, but I didn't I only persisted the symbol reference table in Trill.
Okay. Okay. So that needs to, okay, so we need to continue carry that forward. I guess we also need to figure out what other aspects of the environment are important to be persisted in order to faithfully reconstruct a compilation.
You're going to need the known object table. And that has the interesting wrinkle that you need the objects that it represents.
So right now, is that an OpenJ9 specific thing? I know the known object table is in OMR.
Yes, known object.
It's only used.
I think at the moment it's only being used in OpenJ9. But there's certainly nothing that would stop it being used in OMR, right? It's the notion that you can state specifically, statically, the address of a something, right? So this symbol reference is referring to a thing. That thing happens to be at this address, and you are allowed to peek into that something during compilation, right? So in OpenJ9, they're being used for objects. So we have an object. We know this symbol reference is pointing to something. That something is an object. We can tell you specifically which object at compile time. We maintain a JNI reference to that so that, the pointer moves when the GC runs and everything. Mm-hmm. And you can basically take a lock and then go and peek inside that object and pull through it and look at it and do all those kinds of things. And it's an area that there's more and more stuff being added to the optimizer for at the moment.
Okay. I guess just a sort of a quick brainstorming. Other than symbol references, what else? And the flags and the nodes, maybe the known object table. What else do we have to persist that we can't reconstruct? I mean, I guess even things like front-end questions and that kind of thing.
Yeah.
We don't
things like
quite have an answer for that yet, but
yeah. Well, so part of that, I think, the answer might be is we don't persist some of that. Instead, what we do is provide, well, at least not right away. What we do instead is provide mechanisms for kind of controlling the compiler at a very fine-grained level so that we can set up a very specific sequence of optimizations that will be run.
I don't know that it's the sequence of optimizations. I think you're more interested in things like the OSR mode, the HCR mode. Like there's a whole pile of modes in the compilation infrastructure that govern a bunch of things about the invariants that are assumed by the compiler when it's running and the representation that it expects, right? So while OSR OSR is a funny one because part of the implementation is in OMR and part of it hasn't been factored up.
Yeah.
But the notion of the HCR mode is certainly something that can apply to other languages where you're allowed to have method redefinition.
Yeah, yeah.
Just compressed references.
Yeah, compressed references. Compressed references, shift amount, object layout, right? So like header size.
Yeah, okay. Okay.
Well, there's really, I mean, there's the IL that you persisted, which you can read back and recreate. But in order to continue a compile from that point on, you need all those other states that was in the compilation object.
Right.
Yeah. Well, these are all things that you would want to control if you're trying to exercise paths through particular optimizations or particular code generation pathways, right? Because you want to be able to say arrayless or not, compress references or not, HCR or not.
How are aliases covered under symbol reference table, or assumption that they would be recreated?
They are planned to be created eventually. The prototype I had did not cover that, but that is something that is in one of the list of things to do.
Yeah, I mean, this particular, like the umbrella item for all of this is actually particularly large and in many cases complicated to actually get a, so this isn't, I don't think this is going to be one of the things that gets solved in its entirety anytime soon, even though we can make some progress on it.
Yeah, and I just reiterate the point that there are two different questions, right? There's what does it take to recreate the IL from persistent form?
Yeah.
What does it take to resume a compilation from this point with this recreated IL to complete? Yeah.
Well, and even stepping back from one level of complexity, trying to unit test paths through the code generator or paths through particular optimizations requires that you have to be able to coerce the state of these various control levers, because ops will behave very differently depending on how a lot of these knobs are set.
Yeah.
Okay. Okay. Any more discussion on sort of the persistence of the environment? No? Okay. So another thing that needs work, and this is perhaps one of the more easier tasks, is to improve the Trill coverage of IL opcodes. So like I said, some of those are going to be covered by the work that's happening with AR64, but you know, perhaps not everything is maybe covered. But the one examples that we can sort of think about, and that we already have some issues open for, are switches. It doesn't do anything with exceptions at the moment. Register dependencies are going to be interesting. And there is some debate at the moment about vector opcodes and how much coverage we actually have with we actually have an issue for that, but I think there's actually already some support for some form of them. Someone from OpenJ9 actually added some tests based on those. So, but that's sort of an initial set of the major ones that we know that we need extra coverage on. Supporting a strict mode. So one of the goals with Trill was not only to test valid IL representations, but also to test invalid IL representations to be sure that the validator that we use is able to catch those cases. So it can consume both valid and invalid IL, which is not always great, because if you really do want to be able to know whether or not the trees that you're passing it are invalid, it won't really tell you that. So the idea is to actually introduce some kind of a strict mode where it will report when the IL that you're giving it is invalid. And probably 98+% of the time, that's the kind of mode you want to be in. So adding that kind of a mode is what this is all about.
So one thought about that, Currently in OMR, at least the way Trill is set up, the validator will always be run anytime any kind of compilation is done, whether it's for test or JIT builder or test compiler. Mm-hmm. So in that sense, it will already. So if you give a test, if you write a test case with invalid IL, it will trigger some sort of failure. So what I'm wondering is then, does this mean that what we want is something where Trill will actually catch it before the IL validator runs?
So without even injecting it into the compiler, right?
Yeah.
It'll be caught by the test case harness, I guess,
yeah.
right? While it's consuming it. Well, I guess the value of that would be like, do we always expect that the validator is going to be running? Or would the option be
in a test?
You have to turn on the validator. So if your strict mode could be to turn on the validator, is what you're saying, to make sure that it's in.
Sure.
Well, I think the distinction here, though, is more about, like, so you may see, like, the set of things that is truly useful to test, apart from testing the validator, are those things that are defined to be valid.
Right.
There is no guarantee that the optimizer or the code generator will do anything sensible with invalid IL. I think we all agree that it currently does lots of non-sensible things with invalid IL. So I think that the real question is, when does validation happen during the test is more the thing, because it's the...
Right, so during the test, it always happens right after IL gen.
Right, but the notion that's always existed in the optimizer and into the code generators is that there's currently the paranoid op check mode where after every optimization, possibly even after transformations, you'll run the validator, right?
Yeah.
And that's a trade-off in runtime and memory usage versus performance, right? And, you know, there's a certain, like, sometimes you can get errors that, you know, are made up for by other things later on, right? There are certainly parts of the code that may allow the IL to exist in a transient, non-valid state. Mm-hmm. And so whether you want to run with paranoid op check all the time, right, and have the extra overhead in running the tests, if you end up with a large Trill test suite, then that could be expensive.
Yep.
Versus, well, we'll validate at the start, possibly validate at the end, or something like that, and then strict mode is, okay, and now I will validate every transient intermediate state that I can lay my hands on.
So that's definitely a possibility. That was not how I originally interpreted that, but yes, you're right. So currently, I believe there's certain ops where the validators always run.
Yeah.
Just because historic reasons we've had problems or...
Let's put it this way. When any mere mortal tries to mess with those, you inevitably end up doing something wrong.
Okay. So. All right. So that's why. So those are then by default already being run in Trill, plus because it relies on the IL injector infrastructure, and the IL injector infrastructure always runs the validator right after IL gen. Mm-hmm. So in that sense, it will already reject invalid IL before it even gets to anything after IL gen.
Okay.
So I guess, is there any point ever feeding invalid IL to anything other than the tree validator? And
not as far as
I can see, I don't think there's any point in sending invalid IL to anything other than the tree validator.
So maybe this is also leading into the next point around error handling, which is providing more location-aware, more context to errors that it finds. So even if it did find invalid IL, is it now capable of telling you where that IL, which IL is actually invalid?
Yeah, not so much. It will tell you like
this load, this IL load or something is.
Yeah, it'll tell you this IL load with this node ID, and if you happen to generate a trace file, it you'll be able to find it. But yeah, it will not persist any information about where that node came from.
So to help people write Trill tests, at least pointing out in the Trill source where you stuffed up.
Yeah. Okay. So we may not actually need a strict mode, but we do need more.
Yeah. More error
context
reporting
for that. Allow that to be carried through. Okay. So already is somebody already created an issue for the error handling part of it.
Perhaps you might want a mode on the Trill, like on the Trill execution that basically is just validate my Trill, right? Like I don't actually want to compile anything. I'm writing a new test and I'm about to commit it. I just want basically lint my Trill.
Right.
Trilled it. That almost looks like an anagram, right? Trillint. Yeah, you only need to turn the N into an R.
Those two letters already look very similar.
Trill lurks. There we go. Because if people are going to write unit tests to exercise the code gen or to exercise the optimizer, right? You don't really want to have the whole compiler fire up and everything. It's more I just want to check my Trill, right?
Right. Yeah. Okay.
Oops. Or if the Trill language is updated later on and you want to do some kind of like global replace, and you just want to check if the files are all still valid as part of that replace, right? If there's an update to the syntax or something later on.
Okay, so then you would want validation to be outside of the compiler.
Well, either that or the compiler starts up, gens IL, runs the tree validator, and then shuts down.
Yeah.
Yeah. I mean, I would hate to have duplicated logic as well. You don't want a validator in and out. So
yeah, that was my concern with having kind of both a validator for Trill specifically and a tree validator, checking the same rules.
Yeah. I guess if you had the sort of lint, it would be sort of error, good error messages in the Trill IL gen followed by good error messages in the tree validator. And if you don't get errors from either of those two things, then you've succeeded.
Yeah.
Okay.
Okay.
All right. Okay. So another item on the wish list is allowing the setting of block frequencies when, allowing some means of injecting block frequencies when blocks are actually created. This might actually be related to the persistence task, where you want to be able to preserve what the frequencies are in certain blocks so that you get the same kind of behavior from that. So maybe that's the kind of thing that should move up to there. Does that sound reasonable?
Sure.
Okay.
Or you want to be able to supply some profiling info and allow whatever profiler infrastructure you're using to go and set the frequencies.
Right.
Mm-hmm.
Yes, I mean, if you're going to do end-to-end tests, I mean, there are some incredibly complicated bits of code associated with that.
Yep.
JProfiler frequency reassociation logic is one of those.
I look forward to dealing with that.
Okay.
Well, it's call graph grafting, so.
Right. Okay. Say no more.
Here be joy.
Okay, so one of the things that Trill can't do at the moment, the limitation is when you produce a compiled body to call another Trill-produced compiled body. So basically a Trill method to Trill method dispatch. Main challenge there is that when you try to call another Trill method, it doesn't really know where to find the address of it, or like there's no relocation or symbol information at all. So we're going to need to architect something there to allow that kind of dispatch to occur. And
so I was just wondering what the use case for that was. Like as opposed to having like a compiled native that you wanted to call or an assembly sequence or something.
So that's been the way we've been doing it so far.
Well, like for example, if you wanted to have, if you were testing out a certain kind of linkage, a new linkage, and you wanted to have method A calling method B, you want to make sure that, like, you can't necessarily use system linkage for both of them. You want to use your own proprietary linkage, which means that Trill has to be able to produce both of those. So A calls B. I suppose there's other kinds of tests that would involve.
So, well, one idea with the potential of turning over a rock that I don't really want to be looking under right now is testing with something to do with inlining.
You don't need to be able to dispatch, you just need to be able to IL gen.
Right. So then the question is, like, if you wanted to be able to do both, right, and do like a comparison.
To me, that feels like it's sort of starting to get outside the realm of Trill because you're talking about an actual runtime system at that point. Right?
Yeah.
Yeah, there's the call, but there's all kinds of other gorp that may well be going on at the time. You can't really model the full cost of a call in a real runtime system outside of that runtime system, right? Like, okay, for a statically compiled language, maybe, but for most other languages, the dispatch mechanism is going to be significantly more complicated.
Right.
Yeah. The use case that came up from this has been predominantly linkage around linkage, right?
Yeah.
Like when we're looking at the fast call stuff that.
Right.
Yes, that's true.
I was just wondering if the engineering effort of doing this to be able to test linkages was worthwhile, whereas if you, like, say you were testing a linkage, right? So if you create an assembly sequence that sets up the call, and then you trill that thing to get an address, then you call that in the middle of that assembly sequence, right? So essentially, you set up all the incoming arguments.
Right.
The Trill is going to do something with them and then return some value to you, and you set up the good side.
Yep.
You're checking to see if you've written that piece according to the spec. Check to see if the compiler does the right thing. And then vice versa, right? The Trill is going to gen call, and you make the call to some little assembly sequence where you explicitly handled the linkage, right? Like, if we're doing linkage testing, is it worth building the Trill to Trill thing if the only thing it's going to be used for is linkage? Because you could shim the far side of the call or the near side of the call for Right. Just in assembly and avoid all that engineering overhead.
I mean, specialized linkages are, they're, relatively rare. I mean, it really would depend on the runtime.
Right.
But I think that would be more a reflection on this being a lower priority task than.
Right. There would still be the danger in Trill to Trill when testing linkage that you have matching errors on both sides. Right. If you make the same mistake on both sides of the call, it all goes Right. So again, I'm not saying that we shouldn't do it. I'm just questioning whether the engineering value of doing so.
So I think there was actually maybe one other use case which has to do with if you're able to, say, persist Trill from a compilation, right, and you compiled, so you JIT compiled some method that called some other method that was also JIT compiled, right, and now you've persisted both to Trill and you want to rerun that same compilation and then be able to actually run that code, the generated code. So.
Yeah. I'm not going to say you couldn't find a use for it. I'm not sure how immediately useful it is.
I think there are more pressing concerns now.
There are.
Okay. So one piece of feedback we receive a lot, and it's I think it probably should be higher on the list, but it's actually to provide more documentation and how-to-ness on creating a Trill test case. We typically point people at Leo's video and the copious examples that exist, but I think perhaps a little bit more softer, gentler kind of introduction to how to do these things is probably warranted, and then getting it added to added to the build, I guess you could say. Yeah. So documentation.
If we could have a nice place in the build to put the tests so that they run, or at least it's easy to figure out where to put them. Because like one of the things that at least contributors from OpenJ9 have been asked at various points is, can you provide some tests for this? Yeah. Inevitably, people write tests, but then figuring out how to shoehorn them in.
Right. I mean, so for so figuring out how to get this to work on OpenJ9 is going to be a different item.
Oh, I'm not saying in the context of OpenJ9, but if somebody from OpenJ9 is contributing and they're asked to write a test,
got it.
How do I get the test into the OMR build without?
Because So currently, the story for OMR is you create the test, and if it's in a new file, you add that file to the CMake. If it's in an existing file, the test framework will figure it out. And then the next time you run the PR build or whatever continuous build, those tests will be run. I guess it is worth documenting just how to add to CMake and where that needs to go. So,
because I didn't know that.
Yes. Case in point.
Okay. Okay, and then the last one that I had on my.
Hang on.
Sorry.
Can I interject a bit?
Absolutely.
Before we go to the with documentation, and perhaps we can provide some input on being on the receiving end of this. What we do is we do a RISC-V port, and we hope to show what we have done so far in the upcoming RISC-V conference, which is slightly more than 1 week ahead in Santa Clara. And we show some moderate progress. We can run simple methods like Fibonacci works and simple stuff like that. And it is becoming critical that we use kind of higher level testing possibilities as we implement more substantial parts, because right now we just programmatically construct the IL like the test compiler tests do, but we don't use the injector framework because on the advice of people on the Slack, the injector framework is going away. And it's pretty much impossible because we're working in a half-broken universe anyway, where even things like basic GDB doesn't work and you cannot connect to anything because GDB server isn't written yet for the architecture and so on and so on. So we're living in a world where the tools are very primitive and fighting against you all the time. So basically anything helps, right? So we would like to write our tests in Trill as opposed to just construct the IL programmatically all the time. Especially what was said today in the light of the AR64 work, that there are more Trill tests written in that. So the problem right now for us is that we cannot even run it at all because there are too many dependencies on things working. We cannot even build the thing because there are pieces that are missing on the platform. Like it presumes that JIT Builder already works. Well, we cannot really make the thing work at the level of JIT Builder because it doesn't even work at the level of constructing the IL manually. So what we would like is something very basic that can allow me to just debug the lowest level parts, like instruction selection and binary instruction encoding and those ISA specific things. Yeah, I guess when it comes to documentation, it's like, well, what are the use cases? Like for whom is this documentation for? And I guess we can take like some initial pieces of that to say, okay, well, one use case is for using Trill for this, and here's the caveats we got into, and from approaching from like level 0 point, here's what we did, and so others don't step on the same rakes. If that makes any sense.
Yeah, so it does. So I mean, thanks for the insight into the project that you were working on and some of the problems you were having. So I mean, in terms of the dependencies, I mean, I think we are all in agreement that we need to make as few dependencies. Having Trill depend on as few things as possible is ideal. For your particular circumstance, if Trill didn't have a JIT builder dependency, do you think that you would be able to, would your build problems with Trill go away, or do you think, or are there more problems that you have?
Well, the dependency on JIT builder is definitely like it doesn't, like, it's dead in the water already, right? So it's immediately obvious that with that it's not gonna work. What else might be there? I like offhand I don't know, but definitely we would like to try this and work on this, because this mode of just manually constructing the IL all the time and maintaining this out of the main tree, this is kind of doesn't go very far. I mean, it if you're just looking for testing something simple with 3 or 4 nodes, it kind of works, but then we need something something like Trill. And especially to integrate with other tests that people are writing, for example, in the case of AR64 architecture, that would be, it's one thing to say, oh, okay, well, what do I need? What kind of, what makes a fully working backend? When you already have a bunch of tests that have to pass, or when you are writing a set of tests like that with somebody else working on another platform, that's a much more appealing story.
Okay. Okay, so I think perhaps not on this call, but maybe we should have a discussion around, perhaps on Slack, or we can have another call or something like that, around the problems that you're having with JIT Builder, and just trying to understand why it's not working in the environment that you're in, just so we can get past that. We do want to break that dependency on JIT Builder for sure with Trill. Your question around documentation, the intended recipient of this information is really, I think, for developers such as yourself that are kind of coming to this project or have never actually written a test case before using Trill. A lot of the knowledge is kind of, you have to kind of go searching for it yourself, or watch a video, or look at example tests, but nothing really that says, okay, look, I need to write a test that uses memory and does, X, Y, and Z, and then therefore this is sort of what it should look like. This is where I should put it, and this is how I should get it invoked in my environment when I want to do the testing. It's providing you that very specific and simplified information for that. So I think that's going to help you. For testing, if you're specifically interested in testing the code generator, I mean, I think that what you really want to make sure is that your IL that you're injecting is getting straight through to the back end, so that you can start executing some of those the code that's being produced. I think to that end, you need to choose a fairly simple optimization strategy that doesn't actually do any optimizations. I think
So
does JitBuilder have a no-op right now? Or a very, there's like one with 5 optimizations.
But one of the additions that Trill made was the idea of the mock optimization strategy that lets you dynamically set which optimizations are going to run, and you can just give it an empty list.
Okay.
In which case, things will go straight to the code generator, and even then, you can ask it to skip code generation entirely.
Okay, so I'm sure that was not known. That is not known to most people. So that's probably one of the pieces of information that does need to get communicated out for sure. I certainly hear what you're saying. I know that we need to do more to make this more consumable, which is kind of why we're trying to revitalize this whole effort with Trill. I mean, a lot of it is being driven as well by AR64 and some of the experiences that they're going through right now, and I think you're probably going through the same experiences as well, unfortunately. So perhaps I will ping you afterwards, and we can maybe have a discussion in the next day or so or whatever about JitBuilder and hopefully getting some of your problems resolved. Does that sound good?
Yeah, either that or after the RISC-V conference, because this is like in slightly more than a week, and
okay, no problem.
We're just really struggling with packing things for it.
Okay. Okay. Well, thanks for your input there. Is there any more, I guess just to keep things going here, is there any more discussion on documentation? Any ideas or opinions that anyone has? No? Okay. The last thing that I had on my list wasn't really one that I had. It was something that Matthew, previous developer here, had suggested, and I'm not exactly sure what he meant by everything here, but I think he had some concerns around the values that have been chosen for the const values template that gets and that we use to generate the constant inputs to some of the tests, and whether or not the choice of those constants is actually the best, and they're actually exercising all the corner cases that need to get exercised. So it's really just revisiting those and making sure they make sense. And also some of the tests that they either seem to either use the parameter inputs or the constant inputs, but not combinations of the both. So perhaps writing tests that actually do use both would be beneficial.
Yeah, for the constant values part, that was a helper I created just kind of to get things started. My expectation was that just by using good testing practices, if you have an edge case for your particular case, you will add that to either what const value already provides or just create your own list of inputs that exercises the test cases you need. I figured that a lot of opcodes would probably require a similar base input set, which is why I created const values. But yes, it should not be relied upon as
the one and only set of constants.
Yes.
For every single opcode. Yeah.
Yeah. No. That.
Yep. Okay. Okay, and then I've got a number of suggestions from a few people. From Charlie, who has worked with this and worked with building Trill on different platforms because he's done some work with the various build compilers. This doesn't actually build. Trill doesn't actually build. And I'm going to rely, so I haven't tried this myself, so I'm going to rely on the testimony of others. But so Trill doesn't actually build on every build compiler that OMR actually supports because of the use of some C++ 11 or later features that or C++ 11 features that aren't available on those platforms. So I think the request here is to actually find a way of getting Trill to build on every compiler that OMR actually supports, and that way it would be more available across the board. So presumably what that means is, barring upgrading the build compilers, is to actually remove some of the C++ 11 features that are causing problems. Leonardo, do you happen to know what the...
I did at one point, but as far as I know, everything I was aware of that was breaking builds has been resolved already.
Okay.
So it's been a very long time since I've run on Trill on anything other than Linux.
So this might be a matter of just trying to get it to build on the various platforms that,
yes.
and basically documenting what we see is breaking and,
yep.
and that. So, are you content with fixing this problem?
Sure.
I mean, just in general, removing some of the C++ 11 features that are problematic? I mean, I know there's some philosophical concerns, but...
So, I'm going to say yes, just because as far as my guess is that any of the serious issues would have already been resolved. Mm-hmm. And anything that remains is going to be relatively minor and can be dealt with fairly easily. If it's just like a using declaration instead of a type def, that can be worked with fairly easily. So, sure.
Okay. Any more discussion on that? Okay. And then I've got three other ones for Matthew that he added to the issue already. One is, I think we've already kind of covered that. It's really the ability to output Trill and use it to build regression tests. But in order to do that properly, you're going to need to persist more than just the node information that's there. So I think we've talked about that one quite a bit. So I think we're in agreement that needs to get done. He's also suggested something similar to LLVM's lit. I'm not familiar with that at all, so that's something that I'd have to read through to see if that actually makes sense for this. Are you familiar with that? Or?
Yeah. I think it does make sense. I'd have to think about for a little while to find a way to make it work elegantly. But basically, the idea is right now, if you want to use a Trill, if you want to write a Trill test case, you have to write C++ code and inject Trill code in there as a string or reading it from a file or something along those lines. And then you actually call the JIT compiler or the compiler from C++, call the compiled method from C++, and everything, all of the asserts after that are in C++.
Yes.
And what a tool like lit would allow us to do is instead just write Trill directly to a file and be able to write kind of annotations right in the file that describe how the test case is going to behave. And then the tool reads that in and actually constructs and runs the test case from that.
Oh, okay.
So it would be a much more direct way of writing a test case. I think it also provides certain features for injecting asserts. So that, for example, if you were writing IL, you would be able to inject an assert that some particular node is going to persist after all optimizations and it doesn't get folded away or something.
Do you think supporting something like that, can that be, can that be done later, or do we have to start changing the architecture of Trill now in order to be able to support that? So like we have a whole list of other things that we want to get done.
I don't
probably ahead of that.
I think that two can be done in parallel.
Okay.
Because a lot of basin infrastructure is still going to be needed in both cases. This would really just be creating, at least the way I'm visualizing it right now, you would be creating essentially a new front end where instead of being Google Test, you have this other more complete C++ program that is essentially going to end up doing the same thing, just be data-driven, so it reads what it needs to do from a file and figures everything else out and sets it up to execute the test.
Okay. Okay. Interesting. Okay, I'll have to look at the link that he's got there, read a little bit more about that. Okay. All right, and then I guess the final suggestion that he that he made was the ability to test other dynamic language features, like runtime assumptions and things like that. I agree that eventually this is something that it would be nice to test. I think I would put that as a long-term item. I think that we're a bit of ways away from doing that, but I certainly agree that we need to give some thought eventually to being able to test that. So I mean, I like the suggestion. But,
Well, what I think specifically with that, what we will have to think about is how we're going to use that to test something, right? So before we start thinking about how we're going to get Trill to handle invalidating an assumption, what are we actually testing that requires invalidating an assumption? And that's going to be, I think, what drives that work.
Mostly, I think you'll be worried about the code patching.
That would have been my guess, yes.
Because it's the single hardest thing to get right.
Yeah.
Well, that and the kinks.
Right.
Like, those are the two things that are the hardest to read, the hardest to understand, and the hardest to modify in a way that you don't break everything.
Right.
Generally, if you so much as look at the generator, so it falsifies.
Yeah. So, but just for the sake of argument, though, for something like testing code patching, would we really need to be able to violate a runtime assumption, or would it be possible to just pull out that code patching mechanism and just
well, you need some way of you need some way of poking that code patching mechanism, and I think the assumption invalidation is sort of what ends up poking the
right. So what I'm asking is, could we skip that and just go directly at whatever whatever signal?
Right. You would have to invent a stick to give you to start poking it. Yes. Yeah.
Okay.
Yeah. I mean,
so we're seeing the same thing, just differently.
Yes. Okay. So I guess we have about less than half an hour left. Are there any other ideas or thoughts about Trill that people want to kind of put out there? I guess at the moment, I mean, I'll take any idea, but I guess I'm more thinking about short-term things that we can immediately focus on to make things better. And if not, we can start going through and prioritizing perhaps the work that we have come up with. No? Okay. All right, so opcode tests, replacing the FE opcode tests, I would say that that's already in progress, and it's at the very least medium to high, well, it is high priority because AR64, and I guess RISC-V is going to need that as well, so and I'll put that up on the list. What I actually will do is probably create an issue, an umbrella epic issue, just so that people know that it's happening, and maybe even we can track some of the PRs that are going in where the code is actually being added, so that people kind of know the set that's being built up. Allowing platform and capability specific tests. That we have come across that already when we were testing some of the vector tests, and we ended up actually having to disable some of them. So I know that that's already an issue. So I think that we do need some kind of a solution there. So that's higher priority, if anybody disagrees. Removing the dependency in JIT builder. I mean, people have already come across this problem.
I would say that's very high priority because especially now that JIT builder is evolving.
Yes. Yes, exactly.
It's becoming a lot less feasible to have the two linked together.
Right. So that one's even pushing like top priority kind of status. Yes.
Because right now it already has some hacks in it to get around the fact that JITbuilder has its new front-end API generator. And Trill has some interesting stuff in there going on to get around that.
Yes, it does.
Okay. So persistence of the greater persistence of the environment. That is sort of, I would say, a next step that we like. The next step in the evolution of Trill. I think there are some other things in the way. I would put that at a little bit lower priority, medium priority.
Sure.
Trill coverage of IL opcodes. I'd also have that up at high because I think AR64 is going to run over those pretty soon. Strict mode is nice to have.
So because it's like the IL validator is there, I'm kind of leaning as a lower priority. Maybe we can look at giving better control over what the IL validator is doing, but it is there and it's running already. So.
Okay. Error handling.
Could be medium.
Medium. Yeah. There's some things you can do with that once you have it. Trill to Trill method dispatch, I guess low.
Yeah.
Documentation. You never have to argue with that. Okay. And then revisiting the test case inputs. Low, I would say.
Sure. I think specifically for that one, it will be as we add more tests, just being more mindful of what test input we're feeding into the test cases.
And catch some of those on review as well.
Yeah.
Okay, and then getting Trill to work on all OMR platforms. I mean, I think there's some effort there to figure out what the problems actually are, if they still exist. But it's hard to argue with that one. I think that, but I wouldn't put that as the top priority. I'd put that maybe medium.
Medium high.
Yeah. Okay. And then the other two, the textual test case, the lit work, and then perhaps other dynamic language features, I put them as low. They're longer term items.
Yeah, they're longer term items.
So, okay. So what I'm going to do is make sure that there are issues created for all of these items with at least a reasonable description of what they actually mean. I also know that there are some issues that others had opened already in, there's OMR issues open for Trill ideas. I guess I should go through those and vet them as well. I think they're kind of, some of them may be covered by these already. Some of them are kind of like bugs or that kind of thing. So just need to make sure that that list makes sense at the moment and that those ideas are at least represented. Any other discussion that anybody wants to have about Trill? No? Okay. Well, if not, I think that's the last thing that we have to talk about. So I think we're going to adjourn. So thanks, everyone, for attending. Boris, I'm going to get in touch with you in the next little bit about some of the problems you're having with JITbuilder, if you don't mind.
Thank you. Yeah, thanks.
Okay. All right. Thanks, everyone, for joining. Bye.
Bye.